4.5 Quantitative Data Analysis Techniques. Range rank order distribution, a simple frequency distribution, and grouped frequency distribution. As with all data analysis, the collected data needs to be prepared and organized. When using quantitative data, there is 4 primary ways of grouping this. These are the range, rank order distribution, simple frequency distribution, and finally, grouped frequency distribution. The first is range, which is where the largest number from the data is subtracted by the smallest number from the data. The range is very simple to do and is useful as it is the most simple way and reliable way of organizing data. However, there is a possibility that the data may have an anomaly in it. For example, all data collected being similar except for one number, which may make it invalid. Because of this, it may not be the best way to prepare data. Rank order distribution. Rank order distribution put the data in order of any rank that has been chosen by the researcher. This is used with numbers that are equal to or greater than 20. This can be useful as the data can easily be found by the researcher, making it easy to organize and find data, along with getting rid of any outliers. Simple frequency distribution. The next, simple frequency distribution, which is where one column holds the individual raw data, and the other column is the frequency of the scores, which is how many times the same score comes up. This method is useful because it categorizes both the raw data and the frequency into a table, which are 2 key pieces of information and may be all the researcher needs to categorize the data. However, this data method can only be effectively used if there is 20 or less numbers in the table. Grouped frequency data. This type of data is similar to simple frequency data. However, it categorizes the raw data into groups. For example, 200 to 250 would be one category of raw data. Unlike simple frequency distribution, this method is used with numbers that are above 20 and that have a range of 21 or above, with there being ideally 10 to 20 scores of raw data groups and frequencies. Because of this, it may be difficult for the researcher to pinpoint and extract a specific piece of data that they may need due to the wide range in between the numbers. A bar graph is a graph which uses parallel rectangular shapes to represent changes in the size, value, or rate of something, or to compare the amount of something relating to a number of different countries or groups. This bar chart shows the participants involved on the x-axis, and the y-axis shows the resting heart rate levels. Scatterplot. A scatterplot is a graph of plotted points that show the relationship between 2 sets of data. Each point represents an individual score for both tests. A scatter graph can show a positive, negative, or no correlation. There is a strong positive correlation between the sets of data when a line goes from the bottom left corner to the top right corner, and a weak positive correlation is when the plots go from the bottom left corner to the top right corner. However, the plots are much more spread out over a wider range. A line graph, or a line chart, is a graph which uses lines to connect individual data points that display quantitative continuous values. The line graph is a good method of displaying the data because it easily shows the extent of an anomaly. A box and whisker plot is a graph that presents information from a 3 or 5 number summary, which is the median, upper quartile, and lower quartile. It is especially useful for indicating whether a distribution is skewed and whether there are potential unusual observations in the dataset. Box and whisker plots are also very useful when large numbers from the gathered data are involved and when two or more data sets are being compared. Table. Tables are useful in representing accurate data. It is the most simple way of presenting data for the researcher and is also the easiest way of understanding data for a participant. They display specific amounts rather than approximations, but are more common in other charts. They allow people to understand the data in more detail, although they do take longer to interpret and to understand. A histogram is a plot that displays the frequency distribution in a set of continuous data. It allows the researcher to see any outliers or skew in the data and what the extremes are. Each bar in the histogram represents the tabulated frequency at each interval. Normal distribution curve. A normal distribution curve is a bell-shaped curve that shows how the data is distributed. The symbol at the bottom of the curve indicates the standard deviation, in which you would use to find out the variation of data from the mean value. Standard deviation focuses on the bulk distribution update around the mean, whereas normal distribution analyzes the location of the majority of the data. Asymmetrical and skew distribution curves are when the distribution curve is not bell-shaped and is leaning more to one side, which can either make it positive or negative. If the majority side, which can either make it positive or negative. If the majority of data is towards the right of the curve, the data is negative, and if the data is towards the left of the curve, it is positive. In a normal distribution curve, 95% of values are between -2 and +2, standard deviation. 68% of values are between -1 and +1, which is either side of the mean. Outliers. Outliers are pieces of data that are not similar to other values in the dataset. For example, with a dataset valuing from 1 to 92, 1007 would be an outlier, an extreme which may affect the results of the data depending on what statistic is used. There are two methods that can be used to remove outliers from data, known as trimming and windowing. Trimming is removing the data points from the analysis that are unlike most of the data in the set, and windowing is when outliers are modified to become the next nearest acceptable value. These methods are used to prevent any incorrect results due to one or two anomalies in a dataset. Descriptive statistics. These are the findings of data in numerical form and at a basic level. There are two ways it can be done, one of which being central tendency and the other being dispersion. Central tendency is a single number that represents the dataset, and dispersion is a number to measure the spread of variability of scores. There are three measures of central tendency, which are mode, median, and mean. There are also three measures of dispersion, which are range, interquartile range, and standard deviation. The mode. The mode is the most frequent number that occurs in data, which can be found easily when in a table or graph. However, two modes, which would be known as a bimodal value, may also occur, and therefore we would have to add the two numbers together and divide them by 2. The mode is the only central tendency method that can be used for nominal data. However, continuous data is unlikely to have common values or a mode. Median. The median is a number in the middle when all the numbers in a category are put in numerical order. The advantages of using the median are that they are not affected by outliers and is not heavily influenced by skewed values. However, this can be difficult if there are lots of numbers, as it can be slow to calculate and time-consuming. The mean is every number in the dataset added together and then divided by the amount of values added. It includes every value in the dataset in the calculation, meaning no value is left out, and is closely used with standard deviation and dispersion. However, if there is an outlier, the mean will be completely different to what it would be if the anomalous data was not included, and it can't be used for ordinal or nominal data. Range. The range is the difference between the largest and the smallest value. It is easy to understand and includes every value in the dataset. However, it can be heavily affected by outliers, and it doesn't use all the data, only the extremes. Interquartile range. The interquartile range is a measure of variability based on the dividing of a dataset into quartiles. Quartiles divide a rank-ordered dataset into 4 equal parts. The middle value is the median, and the values either side of the median are divided into 2, making 4 quartiles. The interquartile range shows the range in values of the central 50% of the data. The inside of the upper and lower quartiles. This will reduce the influence of outliers as the range is smaller. However, it ignores half of the dataset. To find the median of the interquartile range, you need to do n plus 1 divided by 2, which will tell you the position of the number when lined up in numerical order. To find the lower quartile, n plus 1 divided by 4, and for the upper, n plus a quarter times 3. Standard deviation is a number that shows how much a value varies from the center of distribution, which is the mean. Using this message, you are attempting to identify how much data is dispersed each side of the mean. An advantage of this is that it gives the same units of measurement as the values. However, it can be difficult to calculate manually. The disadvantage of this is that an outlier will affect the results drastically. Determining data. There are 4 ways in determining data. What tests would be best to use these are the types of analysis, which is testing for correlation or difference, the normality, which is the parent population normally distributed, research design, which is dependent or independent participants, and the level of data, which is the data continuous, nominal, or ordinal. Parametric and non-parametric. Parametric is when you assume the data is normally distributed. The data only needs to be approximately normally distributed. It is more powerful than non-parametric tests because they are more likely to detect true differences or relationships that exist. Non-parametric tests make no assumptions about the distribution of the data. They are used for ordinal or nominal data, and they are usually based on ranks, rather than the actual data. However, they are usually less powerful. The parametric dependency test. The test examines the significance difference between the 2 sets of related scores, which may be related data between one person. For example, systolic and diastolic blood pressure. Because the test is also looking for a difference between participants, the critical value will also need to be found to determine whether this test is significant or not. 0.05 will always usually be the level of significance, as there is a 95% chance that the results are not luck. Independent t-test and critical value. This test is used when you have more than one participant groups and is used to find if the mean scores between the participant groups are significantly different. Once we have found the t-value, we can look at the critical table, which will tell us the significance level of the calculation. If the value of the critical value in the 0.05 significance box is higher than the calculated t-value, this will indicate the test is significant.